And welcome everybody. Now, as Simon had said, there was a previous webinar which covered the basics and went into it in quite a bit of detail. Today, there are some people, I believe, on the webinar who may not have been on that previous one, so I will be covering an amount of the basics again, just to make sure that everyone is on the same page. But when benefits specifically around VDI are important on that particular slide, I will highlight them. So just to kick off, what I would like to do is take a large step backward in time, really to have a quick discussion about where technology has come from and why there is such a change happening at the moment. So if we look back to when I started in IT in the early 90s, which kind of gives away my age a little bit, but applications had dedicated servers. So databases had dedicated servers, email had a dedicated server, file and print had a dedicated server, and certainly within the x86 world. And each one of these was a silo in terms of storage and compute. And that was okay at the time, but I suppose computing power outgrew that methodology, and you just couldn't take advantage of modern CPUs and capacity in servers unless you actually virtualized. So virtualization came along and allowed us to carve servers, very powerful servers, up into multiple virtual machines. And with that came the need really to move from a siloed storage arrangement to a shared storage arrangement. So storage area networks became very prevalent, even though they were around for a long time previously in the mainframe world, etc. They became very prevalent in order to form the foundation for a highly available and highly agile virtualized environment. Because a lot of the benefits that you expect from virtualization don't really happen unless you've got shared storage, because a virtual machine really needs to exist as a file that is visible from all of the compute nodes, so that it can move either intentionally or unintentionally if you've got a HA event. So that was fine until really we had the same thing happen again, in that CPU and compute power continued to progress in terms of capacity, and in fact outgrew again what was possible of the infrastructure. So what we have really now is a very flexible scale-out compute layer, where thanks to virtualization, we can move virtual machines around anywhere, add a compute node, anytime we want, and it's very easy to bring it into a cluster within the compute layer. But the storage layer underneath has stayed in the dark ages, really. It is not as agile and is not scale out, it's scale up, in the sense that once you've reached the capacity of a particular array or cluster of arrays, then really it's a forklift upgrade to go to the next level. And unfortunately, that is not the ideal platform on which to continue designing data centers. So some of the issues we have today because of this three-tier architecture we build our data centers with is that, yes, the compute layer is relatively easy. It's pretty easy to predict in terms of how much compute power we need. There are great tools out there to help us with this. But the storage layer is always a big unknown. And so while we scale out the compute layer one node at a time, one server at a time, we find that there are big surprises that come along when suddenly our storage array is not up to the job anymore, whether it be capacity or more likely performance. And suddenly we've got to move to the next level. And our storage vendor tells us, well, actually, you've outgrown what that array can do. You need to move to the latest and greatest. And of course, these things happen cyclically. So you keep growing the compute tier, either in terms of its width, or you keep upgrading its compute power by replacing hardware, while underneath, every so many years, you suddenly realize that you need a new storage infrastructure. The other aspect of this is complexity. So you've got a lot of moving parts here. You've got the compute layer, you've got the storage interconnect, be it Ethernet, be it fiber channel, or whatever the next thing is. Connecting you then down to whatever your storage array technology is. And you've got different people possibly managing the different layers, responsible for the different layers. And in fact, you may even have different silos of three-tier architecture supporting different applications. So very often, and this is where problems around VDI often arise, is that you don't want to perhaps put your VDI infrastructure on your existing SAN infrastructure, because that's there to support, your Oracle, your SAP, your line of business applications, whatever else. And desktops don't behave well on storage, so you don't want them to impact your existing infrastructure. So suddenly you now create another silo of three-tier architecture, which is going to be governed or managed by the desktop people, but probably needing help from the storage people as well. And now you've got issues around deployment, ownership, etc. So that feeds into the management issues as well. Scalability is difficult because as you scale the compute layer, as you scale your application, it's very difficult to predict when you actually will hit a bottleneck within your storage infrastructure. And like I said earlier, scaling the storage is not as easy as scaling compute, because it happens in much larger increments at much larger cost. Support, of course, is an issue as well, because typically, well, you've got different people perhaps looking after the different layers because of their skill sets and the complexity involved. And you've also potentially got different vendors looking after the infrastructure, or being responsible for the infrastructure too, because again, you've probably gone out and got best of breed in terms of the storage, the compute, and the fabric. So things can easily fall between two stools, as we say, because finger pointing can happen when there's a performance or stability issue. So really, we're in a bit of a mess at the moment. What should our infrastructure look like? If we could start from scratch again, how would we build our data center? So, ideally, it would be simple to manage. It's the old adage that we typically spend 80% of our time and efforts just keeping the lights on. And that's because of the complexity in our infrastructure typically. So we need to make things simple. We need to create a scale-out infrastructure where it's small increments at a time, and there are no forklift upgrades when we suddenly reach a bottleneck or a brick wall in terms of what a particular piece of technology can do. We, of course, need it to be secure. Now, security goes hand in hand with simplicity, because the more complex something is, the more difficult it is to secure. The more moving parts there are, the more areas there are to secure, the more lines of communication there are to secure. And of course, we want our infrastructure to be agile. We look to the cloud providers, we look to the way that they are delivering their infrastructure, and in fact, adopting cloud for a lot of organizations is a way to try and bring in a level of agility so that we can, provision on demand, not have to wait months for new infrastructure to arrive, be tested and brought into production. Things happen quickly in today's business world, and we need to react quickly, and IT needs to react quickly. So, as you'd expect, I'm going to tell you and hopefully prove to you that the solution to our problems here is hyperconvergence. Now, today we're specifically talking about Nutanix because they are really the godfathers of hyperconvergence and invented this market and are way ahead of anybody who is now claiming to do hyperconvergence. So what we want to do is collapse all of the complexity that exists within a traditional, or what I'd now call legacy, three-tier infrastructure model to a small single node at a time infrastructure which has converged compute, storage, and virtualization. And we'll get into that in a little bit more depth. And you can literally scale this up a node at a time forevermore with no limits within the technology. So I know, for instance, one of the largest clusters of Nutanix infrastructure out there is, I think, in the US Army, where it's over 2,000 nodes at this stage, all within a single cluster, and there is no end in sight in terms of where it will stop. So for any, certainly, UK or Ireland business, we will not reach the limits of its capability. On top of this scale-out infrastructure, which combines compute and storage, sits our favorite hypervisor, whichever one you like. Supported at the moment is VMware, Hyper-V, and KVM. And in fact, Nutanix has their own flavor of KVM called Acropolis, which actually comes with the technology, and you can use it if you wish. So there's no lock-in there. While we talked about the benefits, what we want to gain from our infrastructure and how we'd like our infrastructure to look, we're basically ticking the boxes with this type of scale-out infrastructure, which hyperconvergence gives us, in that it's built like the cloud providers build, a node at a time. So there's a lot of talk about creating a private cloud on your own premise to gain the advantages that the cloud providers have. But we're trying to do it typically with, legacy infrastructure. And that really doesn't compute, there's too much complexity there. So to actually have a private cloud, we need to build an infrastructure like the cloud providers do build. And in fact, we need to be able to build what is a private cloud on-premise using web-scale technologies and techniques, but also use actual public cloud services when necessary as well. So there are certain times where it's better to build rather than buy. Sometimes it's better to own rather than rent. And the same, analogies work when it comes to IT. Sometimes it's better to run, your predictable workloads on premise, but using, gaining all the benefits of a cloud provider by using web scale technology on premise, while being able to rent capacity on demand, and really having a seamless view between your on-premise infrastructure and the cloud infrastructure, being able to stretch your data center between on-premise and cloud, whether that be out to Amazon, Azure, or other cloud providers to come. So we can easily back up our infrastructure to these cloud providers. We can provide disaster recovery by replicating out to cloud providers. And while we're saying here we can do seamless application mobility, it is actually from Nutanix something that's coming very, very shortly, and that's the ability to actually move virtual machines running from on-premise to your favorite cloud provider and back again with the migration happening behind the scenes. So really it is about creating that seamless, all-encompassing cloud for both on-premise and public. So we talk a lot about cloud. How did hyperconvergence come about? Well, it's again thanks to cloud. The guys who started Nutanix have come from cloud backgrounds. So the engineers, the management teams have come from the likes of Facebook, Google, and Amazon. So in looking at how these organizations scale their infrastructure, they brought those insights into Nutanix. So Amazon and Google and Facebook don't use the type of infrastructure that we see in our own data centers. You won't see large arrays of storage connected up to, branded compute nodes. Some of these guys actually just design their own, and it's all scale out, with each node being completely disposable in the sense that tasks are not reliant on any particular node. They are scaled across the entire infrastructure. So there you will not see storage, because storage is actually spread across all of the nodes within the data center in the likes of Amazon and Facebook. And it's built using off-the-shelf technology. There is nothing unique about the hardware. It is standard x86 hardware, but the magic is in the software. So the automation, the storage functions, the virtualization functions are all carried out in software. The system is designed for failure. So I know I've seen videos of guys walking around the Google data center with a cart, just taking nodes out, throwing them in the cart, and putting new ones back in again, and making sure the light comes on, and doing that endlessly. And that's how a self-healing system should behave. It shouldn't be a case of building to prevent failure. It should be building to accommodate failure and to actually expect failure. And these are the principles that Nutanix has brought into their infrastructure. So let's take a little look at a logical diagram of how Nutanix actually functions. So if you ever see the picture of a Nutanix appliance, it's typically a 2U appliance with a Nutanix bezel on the front. But behind that bezel, there are typically up to about 4 compute nodes sitting behind that bezel with an amount of flash and spinning disk storage. Each one of the nodes is completely independent. It has its own flash storage, its own spinning disk storage, its own CPU and RAM, and basically combines, all of the nodes combine to create a scale-out file system on which your hypervisor can sit. You have a minimum requirement to create a cluster of 3 nodes, but from there the sky's the limit. Even with 3 nodes, you can still afford to lose one, but really 3 nodes is the initial starting point to create that initial cluster. It is built using standard x86 tin. You can put your favorite hypervisor on top. Within that hypervisor then runs a component called the Nutanix controller VM, and there is one of those per node across the cluster. Within the controller VM runs all of the logic and the magic that Nutanix brings to the table. Each controller VM has direct access to the flash and disk on each one of the nodes, and they all combine then to create a distributed storage fabric across the entire cluster. So as far as your hypervisor is concerned, it sees one big data store. This, of course, can be containerized in order to segment different workloads or to create different policies on different areas of the storage. But in reality, it is just one big pool of storage. VMware will see it as a large NFS share. Hyper-V will see it as a big SMB3 pool, and Acropolis would see it as a big iSCSI target. So as you scale the cluster, you're not just scaling the compute power and adding another node to your hypervisor cluster, you're also adding another CVM, which is really a storage controller, which pools then the new storage in the new node into the overall pool. So as you scale this out, not only does your overall capacity increase, but the actual performance of the entire cluster increases as well, because you're adding more flash, more RAM within the node as well, and of course the horsepower of the controller VM to the overall cluster, which also increases the availability of the overall cluster too. The distributed storage fabric delivers a lot of what you'd expect from a traditional SAN. So yes, it's got very efficient snapshotting, it's got cloning, it's got highly efficient compression and deduplication, both inline and post-process. It has a very important feature called data locality, which basically means that when a virtual machine moves from node to node, as it will, either through a HA event or manually by moving a VM over to another node, then ideally you'd like that VM to access its storage off the local flash and spinning disk. And that's exactly what happens. So even though for resiliency purposes the data is stretched out across the entire cluster, the entire distributed storage fabric, as a VM moves, the system makes sure that all of its data exists, not all of its data, but the data it reads exists within the local node. So a VM never has to stretch further than the PCI bus to the local flash to actually get its data. And there's also intelligent tiering included, which means that the working set of a particular VM will always be stored within the local flash tier. And only when that data becomes cold is it dropped down to the spinning disk tier. So all of the virtual machines across the entire cluster experience local flash performance, and in fact faster than that, because caching also happens within RAM as well. So this will create the fastest possible infrastructure that you could have for your workloads, much faster than even an all-flash array could provide. because even an all-flash array sits out across some form of interconnect on the network or fiber, whereas here, everything is local. This is very important, obviously, for VDI environments because VDI workloads are extremely intensive in terms of their write activity on their disks. So VDI workloads were never designed with shared storage in mind. A copy of Windows 10, a copy of Windows 7, thinks it's talking to a dedicated local disk for its C drive. And once you put any number of VDI workloads onto a storage array, you'll quickly realize that you need not necessarily capacity, but a lot of IOPS. And a lot of write IOPS, which is not what most storage arrays are tuned for. So there's an art in scaling VDI on three-tier architecture, whereas this model completely takes away all of that unpredictability and takes away all of the headaches that VDI would create on a storage area network. We'll talk about that in a little bit more detail later on. So what we're going to get from this is we're taking away those concerns we had with three-tier architecture, those issues we have. So for instance, now we can now buy in very small increments. So rather than buying up front for our 3-year predictions, we can instead buy for what we need right now. So starting with 3 nodes, we can decide, well, this is how much storage, this is how many IOPS, this is how much compute I need today. And if I need more next week or next month or next year, I can just add some more nodes to this. I don't have to make a prediction that will probably be wrong anyway, and suddenly realize that 2 years into my 5-year plan, my SAN hasn't scaled the way I expected it would. It's very rapid to deploy, and it's very rapid to deploy by non-storage experts. Now, I suppose the thing about IT is that, to me anyway, the value in IT comes from the applications. The value in IT comes from the data and how we interact with that data and how we interact with our applications. The storage underneath is a necessary evil in order to support those applications. So really, anytime we spend maintaining, building the infrastructure is time we don't spend on building out our applications, building out our business processes. So this allows us to actually get to the point where we can actually work on our application, whether that be VDI, whether that be SAP or Oracle or Exchange. We can get to that point very quickly without the lower level work of just racking and stacking and then trying to lun out our storage and zone things and all of those complicated things that go with storage area networks. The management is greatly simplified because through a single pane of glass we have visibility of our application performance, our hypervisor performance and alerts, our compute layer and our storage layer. So literally one pane of glass shows us everything we need to know about how the system is performing. Scalability is easy because, like I said, it's completely seamless. Adding another node just involves racking it up, telling it what hypervisor you would like, and then telling your existing management infrastructure to bring it into the cluster. And now what happens is the existing cluster realizes it has more capacity and will grab the extra flash and disk and just extend the storage network out across it and make available the extra CPU for more workloads. So it's very, very easy. Support is greatly simplified because now we're not falling between the cracks in terms of who looks after the storage, who looks after the compute, who looks after the hypervisor. So it makes life much, much easier. These are some statistics which are backed up by various different white papers, which I would encourage you to have a look on the Nutanix website to see. But there are some amazing figures that existing customers have realized. So things like a return on investment of 510% over 5 years. The system pays for itself within 7.5 months. Again, these are examples from various different customers. And a cost saving of up to maybe about 60%. And these are also backed by analysts such as IDC and Gartner. In terms of the benefits to the IT infrastructure, incredibly quick to deploy. Again, up to the application layers. So applications take as long as they take, but in terms of being able to get the infrastructure in place so you can actually start building your VDI or building your SAP or Oracle environment, 85% faster than doing it with three-tier architecture. 71% less time managing the infrastructure. And all of that time can then be devoted to where it matters, working on your application. And downtime is greatly reduced because the system is designed to fail. Small nodes fail, but the overall cluster keeps going. And this is completely seamless to the organization. So what Nutanix has strived to do so far is to make the storage layer invisible. And their aim is to move beyond that. So once the storage layer becomes invisible and looks after itself and is not tying up valuable resources within your organization, then they will move on, and they have moved on, to make the virtualization layer invisible as well. The whole idea is to kind of create this private cloud environment where everything is automated and you don't need to worry about the interconnects between the different layers. So in terms of making the virtualization layer invisible, if we take a little step back about what happened and how, I suppose, virtualization and storage kind of married together in the first place. What you'll find is that because the storage infrastructure didn't understand virtualization, it had a different language of its own, LUNs and LUN masking and interconnects and iSCSI, etc., and all of these acronyms, and was not aware of the virtual machine infrastructure above. It's only aware of individual LUNs. Then the virtualization vendors had to actually bring some of the storage intelligence up into their own product. So for instance, storage services within the hypervisor. Now the thing is, really, this is circumventing or sidestepping the problem rather than actually solving the problem. What you're now doing is you are creating more complexity because you've got storage services within the hypervisor, you've got storage services within the SAN, talking different languages, and it's a bit of a plaster on the problem rather than a fix. So while Nutanix has dealt with the issue of storage services, they are dealt with within the distributed storage fabric. The next layer to look at is the actual virtualization layer. So Nutanix actually has their own hypervisor built alongside the rest of the infrastructure, so it is tightly coupled to what they're doing. It's called Acropolis. And that means that with a system that has built-in virtualization, built-in storage, built-in compute, you can get on with the business of just worrying about running your applications. The cost is also greatly reduced because the virtualization layer is now just part of the Nutanix offering. So other benefits other than cost of bringing the virtualization into the Nutanix layer as well are simplicity. So it's very easy for the Nutanix admin to look after the virtualization layer as well because it's so tightly coupled. I'll show you the console in a little while. It's just so easy to use. In fact, it doesn't really need any kind of a virtualization expert. The same way the system doesn't require a storage expert to look after the system. And with VDI in mind, this is great because the people looking after desktops, you don't necessarily want to have to get these guys highly skilled in storage, highly skilled in server virtualization technologies when they're going to be looking after desktops, which is not easy. It's a black art in its own right. But let them get on with the job of managing desktops and have the complexities of managing the hypervisor and the storage made invisible and done away with. Scalability-wise, with other hypervisors sitting on Nutanix, which is perfectly okay, they're fully supported, you do have the extra issue of the scalability of the hypervisor. The Nutanix cluster can scale forever. Will certainly pass 2,000 nodes, but the hypervisor cluster can only scale to whatever that hypervisor manufacturer has designed it or tested it to. If you scale with the Acropolis hypervisor on Nutanix, the two scale side by side, and you can grow your hypervisor cluster as big as the Nutanix cluster is. So simplifying the management silos, basically. Security-wise, we also have benefits because it's when technologies need to interact that we possibly have security shortfalls, because the two technologies are designed independent of each other and need to talk to each other. Whereas with a built-in hypervisor that is designed within the same team that designs the rest of the solution, it's tightly coupled, and it means that there are less cracks in the armor. So the system is, in general, far more secure. And again, there's a lot of information there from Nutanix around their security processes and how they actually develop their products with security in mind. So beyond Nutanix themselves, there is a huge ecosystem of third-party vendors who are partnering with Nutanix for their applications, for their infrastructure, for their operating systems, etc. So in terms of guest operating systems, we've got full support for Windows, as you'd expect, Linux, various different forms of Linux. Then we've got full support from the likes of Citrix, VMware, and various different vendors like even SAP and Oracle in terms of actually running web applications on top of this infrastructure. So just to quickly highlight the different pieces of the actual Nutanix solution. We've covered in quite detail, I suppose, the underlying storage fabric and the platform itself, which is called Acropolis. On top of that, then, we've got the management framework, which is called Nutanix Prism. And this is the system that gives you the single pane of glass to see everything that's going on. So Acropolis delivering our storage services, our HA, our data protection, the virtualization layer, if you're using the Acropolis hypervisor, the security we talked about. And then we've got Prism delivering that one-click management, so one single pane of glass in which you can see right down into the infrastructure from the application layer down through the hypervisor, the storage, and to the hardware itself. It runs on any platform because it's HTML5 based, so single runtime, as it says, or any runtime. No forklift upgrades, no lock-ins, because it's completely independent of any particular database technology, let's say. So a quick look at the actual Prism console itself, which, like I said, works on anything. And the actual console itself uses Nutanix's own open APIs. So if you don't like this console, or you'd like to actually bring all of this rich information into your own management tool set, well, then the complete API set is publicized and very well documented. And in fact, like I said, Nutanix even built their own console using their own APIs, so that anything you can see in the console is also available to any other system, be it automation tool or management tool that you may have. Unfortunately, I can't show you a demo today, but we really would love you, if you are interested in exploring this any further, to actually do a demo with you, so we can dive into those consoles, see how easy it is to use, see how easy it is to provision new storage, new compute nodes, how easy it is to deliver new desktops, and we can certainly do that with you. Please talk to Simon in Trilogy there, and we can do that. So now, hyperconvergence and Nutanix certainly did, I suppose, find a sweet spot when it came to VDI, because VDI was one of those applications that was putting the greatest strain on our storage infrastructures and needed something new in order to solve these problems. And so Nutanix was a perfect solution there. But it is also a solution for any workload. And in fact, not just virtual workloads, but also physical workloads. Anything that will run on Hyper-V, VMware vSphere, or Acropolis/KVM is a target workload to run on Nutanix, and to gain all of the benefits I've described in terms of scale out, predictability, performance, security, etc. And we're seeing many more people now, maybe having started with VDI as a workload, realizing that they can actually mix other workloads on the same platform. And in fact, that's something you may not have done with traditional architectures because of the worry about, well, what's my VDI workload going to do to my SAP workload? You know, these are at different levels of importance, and I don't want one affecting the other. Whereas the way Nutanix is architected and spread out across an entire cluster with local storage serving the VMs, well, then you can quite easily mix VDI workloads with SAP, with Exchange, with analytical tools, with big data, et cetera, et cetera. And it becomes the platform for everything that you may want to run. And recently, Nutanix has also engineered the system to offer its storage services out to physical workloads as well. So there may be workloads you want to keep physical because of licensing concerns, support concerns, or because they don't support virtual environments. But you do want to offer those workloads all of the resiliency, the performance, and the scalability of the storage that Nutanix offers. And so basically you can offer the Nutanix distributed file system out to a physical workload as an iSCSI target or an NFS share. So let's talk a little bit more about the benefits when it comes to a VDI environment. One of the biggest benefits really is around predictability and scalability. So I know, like, I've been working with Citrix since 1995, and the first question was always, well, how much hardware do I use? And the answer was always, well, it depends, because it depended on the actual workload, how the users operate, and you know, to a certain degree that's still the case today, but there are some great tools available, including from Nutanix, to help you get an idea as to, you know, how many CPUs, how much RAM and such you need. But it was in the storage space really that we had the most issue around sizing, because while you could size a SAN for a certain amount of IOPS, you could support X number of desktops on that SAN. It's when you then hit your upper ceiling and suddenly now, well, that SAN's no good anymore, you need another one. And so we have these large jumps in budget requirements every couple of years or even less when you suddenly realize the SAN isn't up to it. Whereas, as we see here on this graph, if you know, and you probably do know, that a Nutanix cluster of 4 nodes can do 400 desktops, VDI desktops, well then 2 blocks, which is 8 nodes, will do 800. 3 blocks, which is 12 nodes, will do 1200. And it scales linearly like this forever, because you don't hit that bottleneck when the SAN is no longer capable. So very predictable, very high performance, because again, VDI is expecting to talk to a local disk. And in the Nutanix world, it does talk to a local disk. In fact, you know, 99.99% of the time, it's reading off flash. So you get incredible performance for your desktops. The other huge benefit is in the actual space the technology takes up. So I have in a moment kind of a reference architecture diagram showing, you know, 1,000 desktops, and 1,000 desktops could take up an entire rack when it comes to traditional architecture, because of the storage arrays, the switching, the SAN fabric, and then the actual compute nodes. Whereas with Nutanix, you can gain a 90% saving in footprint, because it's all collapsed into small nodes which combine the storage, the compute, and the virtualization, which can be incredibly beneficial in our, you know, our very full data centers, or when we're struggling for power, or when we're in a colo where, you know, space is at a premium and we're paying through the nose for it. So I mentioned that there are some really good reference architectures. I'm going to talk, I suppose, specifically around reference architectures for Citrix at the moment. There are reference architectures for VMware View as well, which are all available on the Nutanix website. It's just that I'm a bit more familiar with the Citrix environment, so I'll kind of talk a little bit about that. But a lot of what I talk about is also just as relevant when it comes to VMware View. So a reference architecture I'd like to point you towards, and again, please download it from the Nutanix site, is one that was done in combination with, I think it was Microsoft and Citrix, for 1,000 virtual desktops, VDI desktops I should say, where each user gets their own VM, be it Windows 7, Windows 8, or Windows 10. And that reference architecture basically put 1,000 desktops into 6 U of rack space. And in fact, it's only 10 Nutanix nodes, so one of those blocks is only half full, which is an incredible amount of horsepower inside a very small space. And remember, this isn't just the compute for these workloads, it's also the storage for these workloads as well. The only extra you would need in that rack is a top of rack switch, maybe one or two, and you're done. You've got 1,000 workloads in that small space. What about hosted shared desktops, which is the XenApp model rather than the VDI model? In that, you can actually get 1,000 XenApp desktops in just 4 U of rack space. And again, that's 6 nodes, which is really only one full block and a half full block there. So there's 4 nodes in each one of those blocks we see. So again, a lot of horsepower in a small space. And these are certified. They are all the stats, all of the sizing methodologies are documented in the reference architecture. So you can take a look and see if it fits with your own estimations on the type of desktops that you would like to roll out. Something else that really helps when it comes to VDI is the way Nutanix looks after the provisioning technologies. So for instance, with Citrix, the most prevalent method there is machine creation services, MCS, which is their ability for you to create a single master image for, say, Windows 7 or Windows 10, and then duplicate that master image X amount of times for all of your desktop users. And there's layering technology there, of course, so that you can have a master golden image for the OS, but then a layer of disk on top of that, which might hold specific applications for different user types or different departments. So MCS, Machine Creation Services, ties in directly with what Nutanix does here. And once Nutanix realizes that there's an MCS deployment across its nodes, it will make sure that there's a copy of the master image on each one of the physical nodes, so that again, desktops are running off local storage, even though your master image is held somewhere else. These are called shadow clones, and this works also across VMware View. Basically, the system is looking for a block of storage that is being read by multiple nodes, and then realizes that, well, this is a master image of some kind. It then marks that piece of storage as being immutable, and then creates a copy or a shadow clone of that piece of storage on each one of the physical nodes which is trying to access it, thereby completely reducing any stretching across the LAN that is required to get to the master build or the master image. This lowers all of the impact of some things like boot storms. The boot storm activity is then completely isolated to the individual node where those VMs are booting, and it becomes a non-issue. So boot storms in the past would be an issue because you'd have to size your SAN for the worst possible scenario when all desktops are booting. In this instance, it's not an issue whatsoever. There's also deep integration between the Citrix management toolset and Nutanix. So for instance, when you are in the Citrix Studio and you're choosing the hypervisor you'd like to create your desktops on, well, one of the options available to you is Nutanix Acropolis. Now, of course, you could also be using VMware vSphere. You could be using Hyper-V on Nutanix as well, and you'll pick the relevant hypervisor here. But there's deep integration between what Citrix is doing and what Nutanix is doing with Acropolis. So your machine creation services, the provisioning tool set, interoperates with Nutanix Acropolis and allows you to create those VMs across the cluster. Vice versa, there's also visibility of things like your HA and your DR plans from within the Citrix Studio as well, so that the protections that you put on those VMs, the VDI VMs, can be tied in with your protection plans in the Nutanix environment. So this is really just a little look into it creating those desktops now on the Nutanix infrastructure. It's worth noting that it's machine creation services only, because provisioning services, PVS, works differently and doesn't actually make use of storage services like this. Yes, you can use provisioning services with Citrix and Nutanix. It's just dealt with it a little bit differently, and there are also huge benefits to be had when you're using provisioning services as well, in terms of where the write cache is located and taking away a lot of the bottlenecks associated with the write cache. Something that's worth noting, may not be suitable for everybody, and that is that Citrix and Nutanix are also, again, deepening their relationship in terms of offerings. So, for instance, announced at the Citrix Synergy just this year was a collaboration whereby through a single line item or SKU, you can actually order from your partner what's called Nutanix Instant on VDI for Citrix. And what this gives you is, starting with a minimum of 300 users, because really, a cluster of 3 nodes supports 300 users, for as little as about 375 euros per user per desktop. This is a VDI desktop. You can have the Nutanix infrastructure, so that's the storage, the compute, the Citrix VDI license, and 3 years of support on that for as little as 375 euros per user. Now, that's less than buying a desktop typically for a user, and what you have is a full virtual desktop environment with all of the benefits we talked about, and not just within the infrastructure, but all of the benefits of VDI as well. Incredibly high performance, greater performance than putting an actual physical desktop on their desks for a very small entry-level fee. Again, mileage will vary because some people will want slightly different types of desktops. Maybe the particular Citrix license that comes with this offering isn't the one you want, but that is certainly a good starting point for anyone wanting to enter into the VDI world with Nutanix and Citrix. There's also deep integration with Citrix Lifecycle Management product, which is a cloud service that Citrix offers, and basically it's an automation tool which allows blueprints which different vendors create to be played out on your infrastructure. So, for instance, there is a blueprint for Zen App and Zen Desktop, which you can literally play against your Nutanix infrastructure, and it will build the VDI infrastructure for you. So layering in the operating systems, the VMs, the actual Citrix pieces as well. And so fully automated, you can actually build an up and running VDI environment by basically going to Citrix Cloud, partaking of the Citrix Lifecycle Management service, and telling it, I'd like to build Zen App on Nutanix, pointing at your Nutanix cluster, and then your VDI is automated and built. And then thereafter, the update service and the smart scaling services within Lifecycle Management can also be utilized to make sure that the management components within your Citrix infrastructure are always up to date. And you can even have the system auto-scale through the smart scale function, so that as new desktops are required, it will actually spread out across the cluster and take more resources as necessary. So very quickly and in summary, this is a kind of a whirlwind tour of really Nutanix and what Nutanix does in the VDI world. And we can certainly get into more depth around your own particular requirements on a face-to-face basis, where we can do demos. We can, do more of a workshop around your particular needs, whether it fits, whether it doesn't. But what Nutanix is trying to achieve here, and I kind of alluded to earlier on, is the fact that they're trying to make the infrastructure part, I suppose the boring part underneath, the pipes and the tin, completely invisible, so that you can get on with the important business of the applications that actually run your business. And it's about turning around that 80-20 rule of spending 80% of your time just keeping the lights on, to spending only 20% of your time keeping the lights on, because the infrastructure is there helping you with that, and spending the 80% in actually getting involved in projects that drive the business forward. And really, this is a technology that it delivers what it promises in those terms. And I really encourage you to investigate it further, either online or with your partner Trilogy. So thank you very much, and I'll just double check that if there are any questions. Simon, do you think you're still online?
Yep, certainly am.
Yeah, Simon, did you have anything to add to that, or anything you'd like me to address in particular or clarify?
No, I think that covered it all well from the early stages of Nutanix through to the later stages. I think maybe some more VMware View information might be useful in the future, but I think that covered everything and gave everyone a good idea.
Yeah, there is, just on that point, there is a lot of VMware View information available online from Nutanix. Apologies if I made VMware View seem like the poor cousin here, but it's just on my own personal, I suppose, experience is more with the Citrix side of things. But VMware is also a close ally in terms of putting VMware View on Nutanix as well. There are really good reference architectures and scaling information and documentation available from Nutanix. So again, I'd encourage you to look at that information. And certainly, if we have face-to-face conversations, we can certainly get into that in more detail too.
Great, perfect. Yeah, thanks, Raj. It's just a quick note for me to say thanks to everyone for attending. I really appreciate you taking the time out this morning, and we look forward to catching you on the third webinar in a couple of weeks' time.
Great. Thank you, Simon, and thank you everyone for attending.
Cheers.